Galvanic cells produce electricity through a redox reaction in which electrons flow from a metal anode to a metal cathode, connected by a wire and a salt bridge. This electricity is a result of the differing electron potentials between the two metals, and this can be measured by the voltmeter connected to the wire. A galvanic cell can be studied as two half cells. At the anode, oxidation occurs as zinc loses electrons that reduce copper ions at the cathode. The cathode undergoes a reduction in which ions accept two electrons. As the electrons are transferred between cells and ions move in and out of solution, the salt bridge between the cells maintains the charge equilibrium so that the reaction continues until no zinc metal or copper ions remain. So let's take a closer look at what is happening in these cells. At the zinc anode, zinc atoms lose two electrons that make zinc 2+ ions that enter the solution. The two electrons lost flow through the metal wire to the copper cathode. At the copper cathode, the two electrons reduce each copper 2+ ion in solution to form solid copper metal. So how can we remember all this? What happens in each cell? Well, you see,
we start at the anode, electrons are lost there, and go through the wire, and through the load on fire. They enter the cathode, and reduce the cations, and the anions go through the salt bridge back to where? Where? We start at the anode, electrons are lost there, and go through the wire, and through the load on fire. They enter the cathode, and reduce the cations, and the anions go through the salt bridge back to where? Where?